granulation and endpoint determination in wet granulation. Granulation, a technique of particle enlargement by agglomeration, is one of the most significant unit operations in the production of pharmaceutical dosage forms, mostly tablets and capsules. During the granulation process, small fine or coarse particles are converted into large agglomerates called granules. Generally, granulation commences after initial dry mixing of the necessary powder ingredients along with the active pharmaceutical ingredient, API, so that a uniform distribution of each ingredient throughout the powder mixture is achieved. Although granules used in the pharmaceutical industry have particle size in the range of 0.2 mm to 4.0 mm, they are primarily produced as an intermediary with the size range of 0.2 mm to 0.5 mm to be either packed as a dosage form or be mixed with other excipients before tablet compaction or capsule filling. Granules are produced to enhance the uniformity of the API in the final product, to increase the density of the blend so that it occupies less volume per unit weight for better storage and shipment, to facilitate metering or volumetric dispensing, to reduce dust during granulation process, to reduce toxic exposure and process-related hazards, and to improve the appearance of the product. Consequently, the ideal characteristics of granules include spherical shape for improved flow, narrow particle size distribution for content uniformity and volumetric dispensing, sufficient fines to fill void spaces between granules for better compaction and compression characteristics, and adequate moisture and hardness to prevent breaking and dust formation during process. Endpoint determination in wet granulation. What is granulation endpoint? Endpoint can be defined by the formulator as a target particle size mean or distribution. The endpoint can be defined in rheological terms. It has been shown that once you have reached the desired endpoint, the granule properties and the subsequent tablet properties are very similar regardless of the granulation processing factors, such as impeller or shopper speed or bind addition rate. The ultimate goal of any measurement in a granulation process is to estimate viscosity and density of the granules, and, perhaps, to obtain an indication of the particle size mean and distribution. One of the ways to obtain this information is by measuring load on the main impeller. Power consumption. Measurements of power consumption of the mixer motor have been widely used for endpoint determination because measurement is economical and well correlated with the growth of granules. Power consumption can also be correlated with mean particle size of the granules, although it is not linear in the entire range. Intragranular porosity also shows some correlation with power consumption. Pharmaceutical high-shear mixers are generally equipped with one or more devices for such measurements. Significant drawback of the power consumption measurement is that it reflects load on the motor rather than load on the impeller, where actual action is being performed and can vary with time regardless of the load. Impeller load. Load on the main impeller can be estimated by measuring current in DC motor because torque generated by the impeller is proportional to the current applied. Current meter, ammeter, can be used for small-scale DC motors. In case of AC motor, impeller load does not vary linearly with the current applied, therefore current is completely ineffective as a measurement of impeller load in AC motor. Power torque method. Impeller power consumption can be calculated as a product of the direct torque, rotational impeller speed, and a coefficient, usually equal to 2 pi times a unit conversion factor, if required. Impeller torque, on the other hand, is directly related to the load on the impeller. It was observed that when the endpoint region of a granulation is reached, the frequency distribution of a power consumption signal reaches a steady state. Banana breaking method. Take wet granules in hand and close the fist, then open and break it throughout the thumb, called a banana breaking method. Ampere load method. Ampere load on the impeller and chopper is displayed on PLC with amp unit.